Hey friends, welcome back to Data Analytics Talks. Being a data analytics professional, our exposure to SQL Server scripting is very essential. Whether you are a expert or intermediate or beginner, you will always have to work with the SQL Server scripting. At least you may be working in Oracle, you may be working with Snowflake, you may be working with some other data analytics platform or data platform. Always we will have to work with the SQL scripting. So understanding some of the best practices or optimization techniques will really add value. So in this session, I would like to discuss about SQL Server subqueries and what are the optimization techniques in that. So you may be asked your basic understanding of subqueries. So a subquery is a query nested inside another query, such as select, insert, update, or delete. So it can be used to perform operations that require multiple steps in a single query. For example, to find employees who earn more than the average salary in the department. As I mentioned, a subquery is a nested inside another query. Here you can see that we have a select average salary from employee where department equal to e dot department. This is a subquery which is nested within the main query, right? So select name from employee E where E dot salary greater than the average of the department salary. So in order to get the average of the department salary, we have written a subquery. The basic understanding of any subquery is it is a query nested inside another query. So the statement will be like either select, insert, update, or delete. So moving on, we will try to see the difference between subquery and join. We have already seen what is subquery, and I know most of you know join. The major joins are inner join, left join, right join, then cross join, self join. So subqueries can be used when you need to return a single value or when the operation does not lend itself well to a join, such as when using aggregation functions. So joins are typically used when you need to combine rows from two or more tables based on related column and are generally more efficient than subqueries. For example, to find employees in the IT department. So coming to practical scenario, you want to know the employees in the IT department. So how do you do with a subquery? You can select name from employee where department ID in, okay, you note that in, select ID from departments where name equal to IT. So this is a subquery. This subquery will return ID of the department called IT from the department table. And in the outer query, we say select name from employee where department ID in the subquery. Okay, this is the subquery implementation to find employees belong to the department called IT. The same thing can be implemented using a join. So select employee name from employee table, join department on department ID in the employee table and ID in the department table where department name is equal to IT. So which is efficient? The join is efficient than the subquery. I hope you understand how to translate a subquery into a join. So we have correlated subqueries. What is a correlated subquery? A correlated subquery is a subquery that references columns from outer query. So in this case, we have a outer query and we have a subquery. Select ename from employee E where E dot salary greater than select average of salary from employee from department equal to e dot department. So e dot department is reference from the employee query, the outer query. So it's a reference from the outer query, right? So this kind of subqueries are called correlated subquery. In the previous query we have seen where department equal to IT, but here we are referring department equal to the department of the employee. So this is a correlated subquery. So this usage of this correlated subquery is not efficient because for each and every row, this subquery will be fired. So how do you optimize using? So we can make this subquery as a table, right? As a table. Look at select e.name from employee E, join, select department, comma, average salary as average salary from employee, group by department, as a department average. This is a virtual table now. Now this subquery is behaving as a virtual table and we join with the department of the outer query as well as the virtual table. Then we give the condition where clause where e dot salary greater than department average salary. So this is a correlated subquery. Then coming to the next scenario, what's the difference between using in or exist? So then if you are attending an interview, maybe use what is the difference between in and what is the difference between exist, which is better? The answer is in is used to check if a value matches any value in a list or returned by a subquery. Exist is used to check if a subquery returns any rows. Exist is typically more efficient because it stops as soon as it finds a match, where in might process the entire list. For example, select name from employee where department ID in, select ID from department where name equal to IT. And the same query can be rewritten using exist. Select e.name from employee where exist, select one from department ID where d.name equal to IT and e.department ID equal to d.id. Got it? So exist will exit when a match is found, but in it does not do that. So in exist is always efficient in such scenarios. So often when you attend interviews, you will get a question like, how can I optimize my subqueries? So there are some techniques. One is that using join instead of subqueries. Then second is indexing columns used in where clause. Then selecting only necessary columns, avoiding in clauses where with subqueries, and start using exist. Always we will have some degree of optimized result when you switch or when you start using these optimization techniques. Another optimizing technique is using indexing. Indexes can greatly improve the performance of subqueries by reducing the number of rows the database needs to scan. For instance, if you frequently filter by a column in subquery, indexing that column can speed up the operation. In this example, we are selecting the name from the employee where department ID in IT. Like we have a subquery where we select ID from the departments where name equal to IT. So in this context, there are two columns, ID as well as name. If you index them, you will have a better results. So fill the results when the data set is huge. Does not make much difference when the data set is very small. Okay, so that's about the indexing. Another important concept in subqueries are nested subquery. So what is a nested subquery? A nested subqueries are subqueries within subqueries. So subqueries are queries within queries and nested subqueries are subqueries within subqueries. Here you can see that we are getting all the departments, employees belong to those departments whose department is Jodo, right? So first we are using the department ID of the particular manager, then getting the ID of that department, then getting all the employees of that department who belongs to John Doe. Okay, so we have one outer query, then two subqueries. Two subqueries. Okay. In order to make it efficient, we can flatten this using join. How do you do that? We have three tables involved: employee table, department table, and manager table. So we join department table with employee table. Again, the department table with the manager table, and you give a condition employee name equal to John Doe. So this nested subqueries can be replaced with a flattened using join. Okay, that's about the nested query. So subqueries in different clauses. Okay, we have subquery in select clause. Select e.name. So here what happens? We are going to get the average salary as a select clause. So select employee name, then select average salary from employee where department equal to e.department as average salary from employee. So this is a direct usage of the subquery in the select statement. So how do you do that? We can optimize by moving subquery to from clause. How? Select e.name, department average dot average salary from employee. We join this as a virtual table, right? We join this as a virtual table, and we use it from the join perspective. So we are removing from the select statement and we are making it as a from clause as a join table. Okay, so this is one other way of using moving the select subquery from the select statement to from clause. So subqueries in the select clause are executed for each row returned by the main query, which can be inefficient. Moving a subquery to a from clause as a derived table can improve performance. Hope that helps you. Then coming to the practical side, we will create tables, department table, then employee table, and manager table, and we will try to execute the query in our SQL Server Management Studio. So let's move on. So we are coming to the database. Let's create a new database. So we'll give a database for subquery optimization. Let me click OK. So let's open a new query. Let's click new query. So I have a set of queries already ready. So first of all, we'll create a table called department. We have ID as a primary key and name as work here. Then we have few entries also. We have IT, HR, sales, and marketing. Let me execute this query. You can also create a new table, a new database, and start creating this, execute. So we have created a new table called department, and I have entered 4 entries. Let's also create another table for employee. It has 4 columns like ID, name, salary, department ID, and department ID points to the department table which we already created as a foreign key. Let me just execute this table. So we have created a table called employees. Then we would like to insert a couple of employees to the table, and we have ID, name, salary, then department ID. So insert into employee ID, name, salary, department ID values. I just execute this command. So we have another table. Employee has some value now. The table is managers table, and manager ID, manager name, and department ID. So manager belongs to some department. That's also mentioned as a foreign key reference. Let me execute that. I also need to insert a few managers into the manager table. So we have manager and their corresponding departments. So now we have 3 tables. So now we have created the table and populated the data. If I execute this query, you can see the data from department, employee, and manager. So now let's start exploring our subquery options. So first of all, I would like to see employees who earn more than the average salary in their department. So this is a subquery we have discussed. We have a query which select employees where salary greater than the average salary of the employee in the department. So we can always say subquery is a query within the main query, right? So this a full query has a select from and where condition. So if I execute this, you can see Elise and Eva, they have employees who earn more than the average salary in their department. Okay. Then coming to the next exercise, how do you replace a subquery with a join? In our case, we want to see employees from the IT department. So in this query, what we have done is we have using as query and subquery. The main query we are using select name from employee where department ID in, then select from department where name equal to IT. So let me execute this. This is using subquery. Of course, this is going to give you data like Alice, Bob, Eve. So this is not efficient. Using subquery is not efficient. So what we can also always replace that with a join. So we have select employee name from employee, join department D on employee.department ID and department.id where d.name equal to IT. So this join is replacing the subquery that we just used before, and we are getting the same response, right? So whenever you are getting an opportunity to replace a subquery with a join, please go ahead with that. Next, we have seen a correlated subquery. What is the correlated subquery? A correlated subquery is when we are referring to a outer query in the subquery that's called correlated subquery. So we have selected employee name from employee E where E.salary. Then we are making a subquery select average of salary from employee where department ID equal to E.department ID. So E.department ID is again referencing the outer query. This is a correlated subquery. So if I run this example, I will get Alice and Eve. You can replace this correlated subquery with a optimized join, right? We can optimize this with a join. So select E.name from employee, join. Basically, we are making as a derived table, like select department ID, average of salary from us, average salary from employee, group by department ID as an average department table where E.department ID equal to department average to department ID and where E.salary greater than department average salary. So this table is again a derived table from the same employee table, right? It's not referring to the department table, but instead it is also referring to the same employee table to have a derived table, and we make a join with department ID of this both employee table and derived table, and condition the department the derived tables average. Okay, so that is the that is called using the join. So let me execute this. This is also giving you the same result. So this kind of correlated subquery can be replaced using join. Then the use of in. So we mentioned that in is costlier than exist, right? So in is used to check if a value matches any value in the list or returned by the subquery. Exist is used to check if subquery returns any row. So exist is typically more efficient because it stops as soon as it finds a match, whereas in might process the entire list. So let me execute this in query. So we have the employees from the department name IT. We are using in. And again, the same thing can be used by exist also. So here we are using the employee name. Exist select one from departments where d.name equal to ILT and d.department ID is equal to d.id. So this is using exist. So both, if you execute both in and exist, both are returning the same result. So there are various ways of doing that. Then we also seen like how are we doing the nested queries. So nested query is a subquery which is again within another subquery, that is nested query. So in practical, if you want to see the department employees belongs to that department where the manager John Doe belongs to. So we have to get the department IDs from the manager, then get the department ID from the departments. Then we are getting all the employees belongs to that department. It is called a nested subquery. Let me execute this. Okay, these people are belongs to the same department which John Doe belongs. Okay. So this is all about the subquery and nested subquery. Now we can similar thing we can flatten using a join. We have department, employee, and manager tables, and we can join employee with the department on department ID and manager on department ID again, and we can use a where clause also, right? Let me just execute these. Both will give the same response. So finally, we are going to have another subquery within the select statement, which finds average salary of that department. So if I execute that, select employee name, then the subquery from the employee table, it gives you like Alice, their department average salary is 68333, right? Then Charlie's average salary is 5030. So the same thing can be optimized moving the subquery to a from clause. So we can optimize by moving subquery to a from clause. Select t.name department salary. So we have from employee, then join select department ID, average salary as average salary from employee, group by department ID. Then we are joining the virtual the derived table on the department ID of the employee and department ID of the derived table. So this can replace a subquery clause from the select statement, and this results also gives you the same response. So we have seen how the subqueries can be efficiently replaced by joins, or how the indexes can support the joins also. How the indexes can support the subqueries to behave better. So these are some of the important areas that we should understand from a subquery point of view. Thank you. Thank you for watching. Let me know if you have any questions around the subqueries and making them efficient. Thank you.